Welcome to The Explainer. All right, today we're going undercover. We're opening up the case file on one of bacteriology's most infamous criminal families, Streptococcus.
I mean, that's a pretty terrifying question, right? And the answer? Well, it lies with a single family of bacteria. We're talking about a family of microscopic culprits that have absolutely mastered the art of disguise, invasion, and even toxic warfare against us. Okay, here's how our investigation is going to go down. We'll meet the family, profile the suspects, zero in on the biggest baddie, look at the aftermath, and finally figure out how we bring him to justice.
All right, first things first. In any good investigation, you gotta establish a baseline profile, right? So, what do all the members of this strep family have in common? And what's the one key test that tells them apart from their main rivals?
So if you get them under a microscope, all Streptococca look like these gram-positive spheres. We call them cocci, and they love to line up in these little chains. They're also kind of picky eaters, you know? They won't grow unless you give them a really rich meal, like a blood agar plate. And here's the kicker. They are all catalase-negative.
And that one feature, that's the first huge clue for any microbiologist. Here's the deal. If you add some hydrogen peroxide, that other gang, Staphylococcus, starts making bubbles. That's a positive catalase test. But Streptococcus? Nope, no bubbles. It's a super simple, immediate clue that tells you exactly which family you're up against. Okay, so now that we know we're dealing with the strep family, we can start to dig a little deeper. Microbiologists, think of them as forensic specialists, use two main ways of profiling to tell one of these dangerous relatives from another.
The first method is all about watching their MO on a blood agar plate. Some of these guys, the ones we call beta hemolytic, they just go for total destruction. I mean, they completely wipe out the red blood cells around them, leaving this telltale clear zone of, well, carnage.
But then you've got others that are a bit more subtle. Alpha hemolysis, that's more like a partial hit. The bacteria rough up the red blood cells, but they don't totally destroy them. And that leaves behind this very distinct greenish color on the agar, a totally different signature. And last up, we've got the gamma hemolytic group. Now, these guys are at the crime scene for sure, but they leave the red blood cells completely untouched. No hemolysis, no foul play against the blood cells. But don't let that fool you. They're still there, and they can definitely still be dangerous.
Now for the second profiling tool. It's called Lancefield grouping. The best way to think about it is like identifying a specific gang tattoo. It sorts all the different strep bacteria based on this unique carbohydrate they have on their cell wall. This assigns them to groups from A all the way to U, giving us a way more specific ID than just looking at their MO. So, with that in mind, let's focus our investigation. We're zooming in on the family's most wanted member, Lancefield Group A strep. You might know it by its scientific alias Streptococcus pyogenes. And this is why S. pyogenes is just so dangerous. Just look at this arsenal. It's got an M protein that's basically a disguise to hide from our immune cells. It's got a capsule for camouflage. It even has something called streptokinase, which is like a lockpick that dissolves blood clots so it can spread. And if that wasn't enough, it deploys these incredibly powerful toxins that can literally send your immune system into shock. With an arsenal like that, it's no surprise its rap sheet is long, with crimes ranging from the everyday to the absolutely catastrophic. You know, on the local level, we're talking about stuff like strep throat or skin infections. But when its toxins get involved, that's when you see diseases like scarlet fever. And in the most terrifying cases, it goes invasive. It causes that rapidly spreading destruction known as necrotizing fasciitis. You've probably heard of it as flesh-eating disease. But here's the thing, the danger from S. pyogenes doesn't always just stop when the bacteria are gone. Sometimes our body's own police force, the immune system, ends up creating this delayed and honestly devastating sequel to the whole infection. So let's break this down. There are two big post-strep problems. First, acute rheumatic fever. This one only happens after a throat infection. What happens is the antibodies we make to fight the bacteria's M protein get confused and start attacking the heart instead. It's a classic case of mistaken identity. Then you have acute glomerulonephritis. Here, all these little clumps of antibodies and antigens clog up the filters in our kidneys, kind of like a plumbing problem. And what's really crucial to remember is that we can prevent rheumatic fever with penicillin, but we can't do the same for glomerulonephritis. Now, Group A strep might be the head of this whole crime family, but believe me, it has some very notorious relatives. So let's quickly run down the rap sheets on a few of its most important accomplices. First up, we've got Group B strep. I call it the silent accomplice.
See, in a lot of adults, it's totally harmless, just kind of hanging out. But for a newborn, it's a potential killer. If it gets passed from mom to baby during birth, it can cause these awful infections like sepsis and meningitis in the baby's first few days. And that is exactly why screening is so important. Next, let's look at the alpha hemolytic duo. On a culture plate, S. pneumoniae and viridin streps can look really similar, with that greenish look. But a couple of key tests will reveal their true colors. See, S. pneumoniae is sensitive to a chemical called optochin, and it dissolves in bile. The viridins group, totally resistant. Think of these tests like a chemical interrogation that forces them to fess up and reveal their true identity. And you better believe their crimes are different. Viridin strep is an opportunist. It causes stuff like cavities, and more seriously, it can infect damaged heart valves, especially after something like a dental procedure. S. pneumonia, though, that one's a major league pathogen. It was once called the captain of the men of death, which tells you everything. It's a leading cause of pneumonia, meningitis, and good old ear infections.
So, okay, we have this super diverse and really dangerous family of bacteria. The big question is, how do we actually catch these culprits, and what are our best weapons to stop them? Well, it's a pretty clear methodical process. You start by collecting the evidence, a throat swab, maybe a fluid sample. Then you grow it in the lab to see how it acts on that blood agar. From there, specific chemical tests nail down the suspect's identity. All of this leads to a targeted treatment, usually penicillin, and maybe most importantly, to powerful preventative tools like vaccines for S. pneumoniae and routine screening for Group B. And that last point on prevention, it's absolutely critical. Just look at this number. Up to 1 in 4 pregnant women are silent carriers of Group B strep. They don't have any symptoms at all, but the risk to their baby is very real. This is what makes routine screening during pregnancy such a simple but incredibly effective and literally life-saving thing to do. Which, brings us to our final big question. For decades, penicillin has been our trusty weapon, but as these ancient bacteria keep evolving, keep developing resistance, our fight to stay just one step ahead in this crazy microbiological chess game, well, it's more critical than ever. The next move is ours to make.